I'm Ms. Matsuoka, and I'm going to talk about how to work with geometric sequences. I'm going to cover three main things: how to find the recursive formula, how to find the explicit formula, and how to find a specific numbered term. So basically we need to figure out what to multiply by each time to get the next number. Then we're going to put that as r in that formula, an equals an minus 1 times r. That's for the recursive formula. For the explicit formula, we get an equals a1 times r to the n minus 1 power. And the last part is you plug in 8 or whatever number you're using for n. Okay, so let's go ahead and get started. The first one. If you look at the first one, to get to the next number, we're basically dividing by 3. But I want to know what we're multiplying by. So to figure out what you're multiplying by, you need to flip and multiply. So that's going to be 1/3. So we're really multiplying by 1/3 to get the next number. So we're looking at, the recursive is the one we're doing first. And the recursive means you're looking at the previous one. So it's an equals an minus 1 times 1/3. An is referring to the current term, and an minus 1 is referring to the previous term. So for example, the way this works is you're saying, okay, 6 is equal to 18 times 1/3. That's how the recursive formula works. Now the explicit formula is kind of cool because it can tell you what, you can plug any number into the explicit formula to give you whichever term that you want. So you don't need necessarily the term before. So we're using the formula that I talked about earlier. An is equal to, now a1. A1 is referring to the very first term, which is 54. So it's 54 times 1/3 to the n minus 1 power. Notice how I have the n, or the 1/3, in parentheses. You don't necessarily have to put the number in parentheses all the time, but I would recommend if you're doing a fraction, you do it, and if you have a negative, you're also putting it in parentheses. That way it's very clear exactly what's being raised to that power. Now the last part is the 8th term. So all we're doing now is we're just plugging in 8 in for n, because n is just telling you which term you're using here. So we do a8 is equal to 54 times 1/3 to the 8 minus 1 power. So it's a8 is equal to 54 times 1/3 to the 7th power. And that's all I really need. Now, you could plug this into the calculator to make it a little bit more accurate and all that, but that's really all I need to see, and just from here it's very easy to just plug it into the calculator. So, okay, we're going to look at our next example. So our next example is right here. Again, we're going to do the recursive formula first. So we have to think about what we're multiplying by each time. Looks like we're multiplying by -2. So I'm going to have an equals an minus 1 times -2. My explicit formula is the same type of idea that I had before. It's an equals a1, which is -5 times -2 in my parentheses to the n minus 1 power. And then my 8th term, same idea. a8 is equal to -5 times -2 to the 8 minus 1 power. So it's going to look like a8 equals -5 times -2 to the 7th power. Okay, below you can see the bonus questions there. So remember, the first thing you need to do is figure out what you're multiplying by to get the next number. Then you're going to do the recursive part using that recursive formula that we have right there. And then you're going to do the explicit formula, which is doing that. And then lastly, you're going to use, I still want you to find the 8th term. So we're still using the number 8 for the 8th term. All right, good luck.